Okay, so today we're looking at the idea of what is known as a combination or a permutation. These are um, these are different ways that we can find total possibilities of an event. Okay, we're going to use our calculator to do it, so I need you to make sure that you're all able to find this on your calculator. So if you are holding a TI-30 calculator right now, here's where you need to be. You need to be looking at the second button and looking diagonally to the right, and you should see a button that says PRB. Do you see that? That stands for probability. If you click on that button, you will see three choices inside of there. You'll see an exclamation point. You will see one that says NPR and one that says NCR. We'll talk about each of those today, but that's what you need to be able to see. If you are holding a graphing calculator, you are looking down the left-hand side. Third one down says math. You see it? Click the button that says math. Across the top, there should be four different categories. You are looking for the one on the far right that says PRB. That stands for probability as well. When you click on that one, you will find the same three things. You'll find other things, but you will find those three things listed, I believe, as the second, third, and fourth option. Is that correct? Okay. And you have the Casio something or other. It's a great question where it's located on here, to be honest with you. Get out of here. Oh, it's in the same spot. PRB.
Yeah, that's why I pressed, but then those things
Right there. NPR, NCR, and exclamation point. So you clearly did not choose it.
Wait. Oh, I picked the second button.
I just need you to be able to find them. We're going to talk about how we do each one of those in a second. Okay? So everybody can see on their individual calculator how to get to those options. We're going to talk about all three of those today. All right? Permutations and combinations. It is. I abbreviated on the board over there. Perm versus comb. Yeah. Got a perm or do you use a comb? You know what I'm saying? All right. Al natural. All right. So the first one we're going to take a look at is the exclamation point. In mathematics, we refer to that as what's called a factorial. Okay. In English class, it's a punctuation. But in math, it's what's called a factorial. And we'll talk about what that means. But that's where we're going to start because a factorial is built into both the combination and permutation formulas that we'll see here momentarily. So ultimately, our goal is to be able to use these two ideas to figure total outcomes. And we'll talk about the difference between them. Okay, so we're going to start with this question and help us to figure that out. All right, Shaquille has a 4-digit passcode to access his email. It's made up of these numbers, 2, 4, 6, and 8. Each digit can only be used one time. So the question is, how many different passcodes could he have? Not what are they? That's not what we're asking here. The question is, how many could he have? He can use the numbers 2, 4, 6, and 8. Okay, so take a second, see if you can't come up with a number of how many Shaquille could have. If you got an answer and you're willing to give it a shot, let us know what you got. What do you think? 16. I'll just safely assume you did 4 times 4? Yeah. Okay. Anybody second that thought? Okay. It's like a board, right? Anybody got something different? I appreciate the guess. It is not correct.
20.
Okay. 20? How did you come up with that?
I just have it.
You just threw a number. Oh, you had 2 plus 4 plus 6 plus 8. Okay. All right. Okay. Where are you coming up with that? Oh, just your favorite number? Okay.
I don't know how to do
That's okay.
Yeah, wait.
Whoa. Okay. Well, let's do the.
384.
All right. So, correct answer is 24. Okay. Well,
I know
how?
Because they all can make 24.
That is true, but no. That is true. Even numbers will help that thought process.
And it's 20, and then there's a 4-digit, so it's 20 plus 4.
Okay.
Am I wrong?
Yes. Yes. So the all right. Here's the big piece here. Every one of the numbers, whatever they are, you can only use them one time. All right. So when he goes to make his passcode, how many choices does he have for the very first number? He has 4 choices. He can put a 2, a 4, a 6, or an 8. He has 4 possibilities that he can put in that spot. When he goes to the next spot, how many choices?
3.
Now he's down to 3. Whatever this first number was, he chose a number here, and he's down by 1, so he's only got 3 choices left. After that, he's down to 2 choices, and in the end, he doesn't have a choice. He's got 1 number left, and it's got to go there. If you take 4 times 3 times 2 times 1, okay, you will get 24. That is how I got the answer. Okay. When you take a number and you multiply it by all of the remaining values down to 1, okay, so sequentially work down, that is what's called a factorial. And in this case, we would write it as such. So if you took your calculator and you typed in the number 4, and then you went to the probability button and you found the exclamation point, you would get an answer of 24. True? Okay. Now, when you're talking 4 factorial, that's not really that hard. You probably could multiply that in your head, or you could, type 4 times 3 times 2 times 1 if you needed to. If you were talking like 12 factorial, now you're talking 12 times 11 times 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. You're not doing that in your head. And that's also kind of long to type out. So the use of the factorial would be much nicer in that situation. Are you with me on that? What's up?
I just don't get how you got like 4, 3, 2, and 1.
Well, fine. Make a code right now. All right. Here are your choices. You can use a 2, a 4, a 6, or an 8. Pick a number. Okay. So at that point right now, how many choices when you picked the 2 did you have? Huh? You were allowed to pick from a 2, a 4, a 6, or an 8. You had 4 choices. But the moment you took the 2 off the board, okay, because everything can only be used one time, pick your next number. Sure. How many choices did you have to pick from? You had 3 choices, right? You had the 4, you had the 6, and you had the 8. So you chose the 6. So now you have 2 choices left. You can either choose the 4 or the 8. Well, in that situation, because as soon as I pick the next number, okay, fine, I pick the 8. Now I've only got 1 number left, and it has to go in the last spot. Well, now that depends. Are we talking about a 6-digit password? And I only have 6 numbers? Then yes, it would be 6 times 5 times 4 times 3 times 2 times 1. If you're saying, hey, you got 6 numbers and you got to pick 4 of those 6 numbers, now that changes. And that's going to get into one of these 2 categories called a combination or a permutation. But when it's straight up, like you got 5 numbers and you got to use all 5, absolutely, that's a factorial. All right. So a factorial could be any number multiplied by all of the values after it. Okay, you don't need to write, like you don't need to write this down if you don't want to. That's not really that big of a deal. We say it as factorial. We write it as an exclamation point. There is no need to write out 5 factorial and then right next to it say it is 5 times 4 times 3 times 2 times 1. That's what it means. There's no point to do them both. You with me on that statement? Okay. Are we okay to move? You want me to just tell jokes for a minute? I don't know. She decides. Tell you a joke? I don't know any. I'm sorry. Yeah. Be nice.
What do you call a dinosaur with a great
You gonna give me one of those at the end?
What do you call it?
I don't know.
A thesaurus.
Go ahead. He's actually yeah, he struggles. All right. So try this one. Were you still writing that? What were you writing? All right, you got 5 friends here: Jamie, Shayna, Otis, Abigail, and Ernesto. I love the names that they use. I love them. Ernesto. I think Otis actually is my favorite, to be honest with you. Okay, so they're gonna line up on the beach to take a picture. All right, everybody's got to get that one magical beach picture before they leave, right? How many different ways could they line up next to each other? You got 5 friends. How many? 120. How'd you do it? I know, they're not even ready. You already have an answer. Why? Okay. You got 5 friends, right? If you think about them having to be in one of 5 spots, then the first spot has how many choices for it? 5. Then the next spot has 4, and then 3, 2, 1. Now, I'll even tell you what's the matter. Nice. If you were really going to take a picture, you actually wouldn't talk about the first spot as the place to begin. Think about it. If you were taking a team photo or you were taking any type of photo, where do we put the first person typically? In the middle, right? We build from the middle out. We don't really start at the beginning and work our way across, right? Right? So even if we started right here in the middle and said, hey, there are 5 options for who could stand in the middle, and that's not even really true, right? We put the biggest person in the middle typically, or we put the most important person if it's like a wedding photo or something like that, right? In the middle. But even if we started in the middle and then said, well, one of them had to be out of here, so now we're down to 4, and then we're down to 3, and then we're down to 2, and you're left to be on the end. If you multiply these together, what's true about the multiplication of numbers? They all multiply the same. The order doesn't matter. So that's still an example of 5 factorial. It's still 5 times 4 times 3 times 2 times 1. And that still results in 120 different ways it could happen. Okay? Does it? All right. Now, we're going to get into the idea of what's called a permutation and a combination. When you talk about a permutation, you're talking about a situation where the order of the events matter. Okay? So I'm going to use wrestling as an example because I think we see this happen most often there. At the end of the tournament, there's a podium. And there's somebody who won that weight class. And his podium place is what in relation to everybody else's podium place? It's higher. Why is it higher?
He's higher.
Because he physically it is like a sign of dominance, really, is it not? Right? My podium, like if I won, I'm not standing on the 5th place podium, bud. Where am I standing? On the top. Why? Because I beat every one of you and I'm standing at the top of the hill. Right? Okay. 1st place podium is higher than 2nd place. 2nd is higher than 3rd, so on until you're the guy that's on the ground or the guy who ain't even there.
2nd place is first loser.
That is, if you ain't first, you're last, right? Okay. The order is important. Now that's different than, let's say we got a track meet tonight. We're going to go to the pack track meet. Okay. And there's going to be a qualifying heat for the 4x1 final. All right. In the qualifying heat, your goal is to do what? It's not. It's really not to win. Not in the qualifying heat.
What, lose?
Yes, your goal is to lose, Destiny.
Your goal is to what? Okay.
No, nobody even cares about winning. They just want to see
Okay.
That's literally all anybody.
Well, that's okay. So here's the deal. When you talk about a qualifying heat, you're talking about taking the top so many placers and advancing them to the finals. Okay. And if we say the top 3 move on to the finals, maybe let's say there's 3 heats. And so we're going to take the top 3 out of each of those. Let's just say. If I finish 1st in my heat, do I move on?
Yeah.
If I finish 2nd, do I move on?
Yeah.
If I finish 3rd, do I move on? Okay. The goal is to move on. I might like to win, but I don't need to win in order to move on. Does that make sense? Okay. So in that scenario, that's not a permutation because the order isn't important at that moment. Okay, in the finals, it's important because now if I win, I won, right? And if I didn't, then I didn't. And so I need to be able to understand the difference between the two. And so we're going to look at scenarios, and it's going to be your job to figure out, is it important? Does the order matter, or does it not? All right. Now, in your calculator, you see a picture that looks like this when we see a permutation, right? You see one that looks like that, and you see one that has a C in the middle. Obviously, the P stands for permutation, and the C stands for combination. Okay. What we need to be able to determine is, what do these two letters stand for? Okay, not quite. So N stands for the number of items that's in your sample, essentially. Like, how many? How many things are there that we're talking about? Okay. A minute ago, Maddie asked the question about, well, if you had 6 things, do all 6 of them have to be in there? That was a factorial. If it's, I got 6 things, but only 4 of them need to be there, now it changes. Here's where it changes. Okay. How many do you have? And over here, it's the number that you want. So if we're talking about, there's 8 people in the race, and first place gets $100 and second place gets $50 and third place gets $25, then my numbers are 8 because that's how many people were in the race. And we're going to take the top 3 people, first, second, and third. So that's how it gets a 3. Okay. And because we're talking first place, second place, and third place, the order is important. You with me on that? So let's look at an example of how that works. Okay. Now, this is just the formula inside your calculator that's behind it. Okay. In an effort to provide the most secure and reliable security to its users, Apple requires a 5-digit passcode made up of the numbers 0 through 9. No digit can be used more than once, and how many different registration codes are possible? Do you have a code on your phone? Okay. If you do, whatever those digits are, whether it's a 4-digit or a 5-digit or an 8-digit or whatever it is the order in which you put them in important? Sure. You can't just randomly put in the same numbers in the wrong order and get it to work. Okay. That's what makes it a permutation. It's important. Now, in this problem, how many items are in my sample? I'm allowed to choose from what numbers? 0 through 9, which is how many digits? It's not. It's 10. All right. That's 10 numbers. So this number here is going to get replaced with a 10. Right? If you counted 0 to 9, you would get 10 numbers. And you must pick a 5-digit code. So on the other side, I want the number 5, right? I want 5 of them. So this number here is going to get replaced with a 5. So actually what I'm saying is I have 10 items, a permutation of 5 ways. Okay? Now, just so we're all on the same page, Aubrey and how many others have a calculator like this? Ruby has one, a new version. Yours is going to look. Yours, when you type it in, is going to look like this. Yours might too. Everybody else's, we all are going to do this. We're all going to put the number in first, but when we hit the NPR button and then the 5, that's how it's going to show on our screen. Yours looks like this one. Aubrey, when you do this, you're still going to type the 10 first, but then when you hit the NPR button, it's going to slide that number in the first spot. And when you hit the 5, it's going to slide it into the second spot. So it's going to look like, type in the 10. Go to math. Over to probability. We want the second one.
Oh.
Yep. See how it put the 10 in the first spot?
Oh,
and then the 5. So, right. So how many different possibilities are there? 30,240. Okay. So stop for a second. If you have a TI-30 or an older graphing calculator, it is going to look like the bottom one when you type it in. If you have a newer graphing calculator, it is actually going to put those numbers into those spots. Are we on the same page? Okay, so it's still the same. We enter it the same way. It just looks a little bit different on that side of things. Okay? That was the point where we started at the beginning. You hit the probability button.
Yeah, I know that, but I'm saying like, to put the pen in and then to put it in.
We're a little slower than we met here.
I'd agree. Okay. Now, on the other side of things, a combination. It's exactly the same thought process, except now we're talking about the order isn't important. Okay. Now, here's where this is going to be a little confusing, I would think. If we talk about what's in the hallway out there, those are lockers, and every locker has a combination on it. By mathematical definition, a combination is when the order of the events doesn't matter. Well, yeah, buddy, does that matter? Not only do the numbers matter, the order in which you put them in matters, the spinning of the dial, all that matters. That is a permutation to the end, but they're not called that. I guess apparently when they decided to make them, it didn't sound cool enough to call them permutations, so they called them combinations. I don't really know. Okay, so that's going to be a little bit tricky to think about. A combination, the order does not matter. All right, so here's an example of something where it doesn't matter. So next year, the Model UN, okay, that's a club here at school, consists of 12 people. Right now, there are 4 seniors, 5 juniors, and 7 sophomores who have expressed interest in being a part of it. Mr. Jones will need to decide 12 out of those who have expressed interest to join the club for next year. The order is not important. If you said you would like to be part of it, your hope is that you're one of the 12. It doesn't matter if Mr. Jones contacted you first, second, third, fourth, or 12th. As long as he contacted you, what does that mean? You're in. Okay? Now, it might make your little heart feel better if he called you first, but you have no idea about any of that. That's why this is a combination. The question now becomes, what number goes there and there in this situation? Remember, the left side is how many are in my sample. How many people are wanting to be a part of this? Not 12, 16. 4, 5, and 7. That's a total of 16. That's how many people have said they want to be a part of this. How many people is he going to take? 12. So on the right side, a 12. Listen, these two numbers could be the same. There's no way that the number on the left can be smaller than the number on the right. You would be trying to say you want more than what you have. That makes you greedy. All right? That can't work. So, how many different possibilities are there? 1,820. Okay. All right. For a moment, let's remove the numbers and just look at these 3 situations. I want you to read the 3 situations and decide, is the order important? If it is, that's a permutation. If you read it and say the order is not important, that's a combination. Take a second and read those and tell me which one you think. And we are like running real late on time, so we're gonna have to move. I'll give you like 90 seconds. Simply put down a P or a C. If you think it matters, put down a P. If you think it doesn't matter, put down a C. Three choices. Some kind of special right there. How many times is she just going to keep doing the same thing, expecting something different to happen? Yep. That worked out well. Any taker for the first one? Matt, what do you think? Okay. And if you want to change something along the way, we can do that after we get these 3. What do you think? Next one. No? Next one? Again, okay. Last one? Well, we'll deal with that in a second. How about the third one for a moment? Let's get an answer down to each one. Okay, so we're going permutation all three. All right. Now, Ruby, you said you want to move that one? Why? Okay. We had a fire drill today, did we not? Did you go outside? As long as you were in that row, were you okay? Agreed, right? I need to make sure you're there. Am I going to lose my cool if John was the first guy to walk out and he's not the first guy in line in the thing down there? No, I'm going to stand at the door and I'm going to count and make sure that if I had 18 people walk out the door, the same 18 people are down there, but I don't need them to be in the same order they were in. So I would say the first one is a combination. I would agree with that. How about the next one? Is that correct? Yes. The order matters, right? Player number one, we're not done, so I'm not sure why you guys are going, but I guess you think you need to leave. We have 4 minutes, though. What about the last one? A teacher assigns and selects the order of 5 students. If they selected the order, it matters. Okay? That's different than saying this, hey, I need 5 of you guys to volunteer to present tomorrow, versus saying, hey, 1, 2, 3, 4, 5. You guys are up tomorrow. You're like, oh, crap. Right? Or you're going, yeah, like you left me out of that, right? If the volunteer option is open, you can choose to jump in there, right? Let me go first. So in case somebody's good, mine's in front of theirs, and I don't have to try to follow that one up. Okay? We've all had that thought process too, right? Okay. So this is what your homework looks like. Something like this. You're gonna have to read the question and make the decision. Is it a guess you decided you were done? Oh yeah. As I read this, is it a permutation or is it a combination? And then we'll talk about what numbers are going to need to go into those spots. So what letters go in there? What numbers are going there? I don't have it.
Okay.
I'll send it to you.
Thank you.
Okay. Does the order matter? 16 people sign up for a tape. Well, I love me some ping pong. All right. If the players are put into groups of 4, what's the probability that we get Heather, Aaron, Michelle, and Patrick into the same group? Does the order matter? No. We need those 4 people together. Does it matter which one gets said first, second, third, or fourth? No. So that is a combination. Okay. Now, how many are in my sample? I disagree. 16 people signed up. What number goes on the other side? A 4. And now we can figure out how many total possibilities there are. Okay? You got to have that before you pick the calculator and try to make a decision. All right? And in this case, you would say the final answer is 1,820. Okay? The questions on your paper tonight for homework. 4 questions at the top. Just you need to put down P or C. After that, then you will do this part here. Okay? I told you I would get your homework, so if you have it, I will pick it up.
Do you still want my